In this video, we are going to study coefficient of determination in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice included within it. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding package. Therefore, we're going to comment this as step 1, which is package. And we're going to import statsModels.api as sm. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.formula.api as smf. We're importing that feature from statsModels for our multiple linear regression calculation. To run these two code lines, we go ahead, select them, and we either click the Run Selection button or F9 on the keyboard. Then we continue with step number 2, which is data. For this, we're going to create an object which is house prices underscore object equals to sm feature from statsModels dot datasets dot get underscore r dataset, and we open parentheses. Within it we have the following parameters, which is data name equals to house prices, comma, and enter on the keyboard, package equals to, within quotations, AER, comma, cache equals to true. So what we're doing here is we are downloading house prices object from our package AER, and with cache equals to true means that this saves the data locally, so we don't need to go ahead and download it every time we run the code. So notice that this creates an object, which is the house prices object, which includes both data and documentation. Therefore, we're going to create an object which only includes the data, and we're going to name it house prices, which is equal to house prices underscore object dot, and we get its data attribute. To run these code lines, we go ahead, select them, and we again either press the Run Selection button or F9 on the keyboard. So if we go into the Variable Explorer within Spyder, we see the two objects being created, house prices with the data and the house prices object with data and the documentation. So the one with the data, if we double click on this cell, we see the data. In this video, we're only going to focus on the first 3 columns of data of price, lot size, and bedrooms. If you want to read the full documentation on this data, you can do so with the following code line, which is print, and from house prices underscore object, we get its dot 2 underscores doc 2 underscores attribute, which is its documentation, and at any part of that code line, we press F9 on the keyboard. And notice that again, this prints the documentation within the console, so if we scroll up, we see house prices are documentation. So now we continue with step number 3, which is the model. For this, we're going to fit a multiple linear regression. Therefore, we're going to create an object named MLR, which stands for multiple linear regression, equals to SMF feature from statsModels.ols, which is ordinary least squares, and within it we have the following parameters. The first of this, which is formula, equals to, and within quotations as a string, we have price as the dependent or explained variable, which is being explained by, with a special character, independent or explanatory variables of lot size plus bedrooms, comma. Now we press enter on the keyboard. Data equals to the house prices object we created above, and we fit this regression. Again, to run the code lines, we go ahead, select them, and press F9 on the keyboard. So now that we fitted this regression, we continue with the following step, which is to print its results. So step number 4, results. For this, first we're going to print, and within parentheses from the MLR object, we're going to get its summary method. Open and close parentheses, and at any part of that code line, we press F9 on the keyboard. So notice that within the console, that printed the summary results from the regression. So if we scroll up, we have OLS regression results, several details about it, and specifically we're going to focus on R-square and adjusted R-square. An important observation here is that as we have a multiple linear regression, it is a coefficient of multiple determination. So first we have here the R-squared right here, which is the percentage of the variance of the dependent variable being explained by its relationship with independent variables. And then we have the adjusted R-squared, which is the percentage of the variance of the dependent variable being explained by its relationship with independent variables adjusted by degrees of freedom. Also, we can go directly and print the values of the R-squared and the adjusted R-squared. We can do so here with print, and within parentheses from MLR object, we get its R-squared property, and also with print MLR object, and we get its R-squared property underscore adjusted. So again, we select the two code lines and press F9 on the keyboard. And we see the two values being printed. First the R-squared and below the adjusted R-squared. And if we see these two values, they are the same as the ones we had right over here at the top. So with this, we finished this code file, so we go ahead and save it. And with this, we finish this video. Thank you for watching.